So we're into the third part of this problem. We're now given that g is defined as 3 plus the integral from -2 to x of f of t dt. On what values of x does g have a point of inflection? And so as we think back to our do now again, we will have a point of inflection when g prime, the derivative, changes from increasing to decreasing, or the opposite, from decreasing to increasing. And you can sort of see from the pictures we've made here, we're really looking for a min or a max, but we're going to use this language here for our justification. So here I need to see what g prime is. So if g is given here, when I take the derivative of the left, then I'm going to take the derivative of this entire right side, and the derivative of the constant 3 will be 0. So as I think about g prime, that's going to be 0 plus, when I take the derivative of the integral of f of t, because this limit is an x and not a 2x, its derivative is 1, so I'll have 1 times the derivative of the integral. Those are going to cancel out. I'll just have 1 times f of t with that x plugged in, minus 0, because that lower limit was a constant. So I'm really just looking for, I can relabel the graph of f as also g prime of x. And we talked about looking for a max and a min. That's where my derivative changes from increasing to decreasing, or decreasing to increasing. So my values would be at x equals 0 and at x equals 2. And the reasoning we should write is g prime, which equals the given graph of f, changes from decreasing to increasing, and at x equals 2, g prime of x, which equals f of x, changes from increasing to decreasing. Lots of things happening in a problem like this, but it all starts with that fundamental theorem of calculus. I was asked about g. Only g prime can tell me about g.